Beneath these mountains lies a well-guarded secret. Over 90 meters underground, deeper than the height of the Statue of Liberty, Iran built the Fordow nuclear facility. This massive subterranean complex is reinforced with solid rock and concrete, housing a uranium enrichment center buried so deep it is considered the most secure nuclear site in the country. The scene shifts to a shadowy hangar where a massive bomb is being prepped. It's the GBU-57, a 30,000-pound massive ordnance penetrator, MOP, the Pentagon's most powerful bunker-busting weapon. Its mission, to destroy what no conventional bomb can reach. Here, two giants of engineering face off, an apparently indestructible bunker and the world's most powerful non-nuclear bomb. Can a single weapon shatter the unbreakable and eliminate Fordow? The GBU-57 MOP is a 6-meter-long projectile, carrying over 2,300 kilograms of high-powered explosives inside a hardened steel casing. It has been tested to penetrate up to 60 meters of concrete or 40 meters of solid rock before detonating. Guided by GPS and inertial systems, it can strike with extreme precision. Additionally, its smart fuse detects internal voids and delays detonation until it reaches the target chamber, technology specifically designed to defeat buried structures. Facing it is Fordow, a uranium enrichment plant located between 80 and 90 meters beneath a mountain. By far, it is Iran's deepest underground nuclear facility. Protected by granite bedrock and multiple layers of reinforced concrete, its rooms and centrifuges are set within what can be described as a bunker within a bunker. Fordow wasn't simply carved out, it was deliberately engineered to withstand attack. The surrounding rock, limestone, dolomite, and basalt, is tougher than standard concrete. The facility was likely designed to endure earthquakes, as it sits near active fault lines. This enables it to absorb impacts that would easily destroy other underground structures. Above ground, the site is guarded and discreetly concealed. It was originally an IRGC military base, providing additional military-level defense. In essence, Fordow is a fortress built to withstand any conventional strike. This is the ultimate showdown. The MOP, the pinnacle of U.S. bunker-busting technology, versus Fordow, Iran's most advanced nuclear defense engineering feat. But the critical question remains, can even the most advanced weapon reach something buried this deep? The B-2 Spirit stealth bomber, the only aircraft capable of deploying the 30,000-pound GBU-57, flies high above. The bomb drops at high speed, gaining momentum and kinetic energy as it plummets toward its target. Upon impact, the 6-meter projectile punches through the ground at supersonic velocity. Its hardened tip and alloy steel body drill through rock and concrete like a massive jackhammer. Each layer it penetrates slightly slows its progress, but its design keeps it intact and burrowing deeper. The GBU-57's true power lies in its smart fuse, which can detect voids in the underground structure and wait for the perfect moment to detonate deep inside the target. As the bomb pierces Fordow's defensive layers, its advanced sensors detect when it has reached a protected cavity. Only then, deep within the target, does it activate its 5,300-pound warhead, triggering a massive underground blast designed to collapse the facility from the inside. But Fordow doesn't yield easily. The first line of defense is nature itself. Tons of dense rock absorb much of the released energy. Shockwaves dissipate through these resilient geological formations. Iranian engineers added artificial defenses too, interlocking layers of concrete shield critical sections. Even if the penetrator breaks through one ceiling, another barrier could be just below. Inside, sensitive equipment may be mounted on shock absorbers, while concrete and high-strength steel pillars add extra buffering. The bedrock isn't uniform either, centuries of tectonic stress have fractured it. These cracks and angles can deflect the bomb's trajectory, like a ricochet, reducing its depth of penetration. Fordow was built to withstand not only direct strikes but also earthquakes. Its overall structure is incredibly robust. Even if part of the complex is damaged, other sections may survive or be quickly restored. This is a true clash of military engineering titans, overwhelming kinetic force versus extreme structural fortification. The GBU-57 was designed to collapse tunnels in one devastating hit, but Fordow was built to resist exactly that. Some believe this bomb stands a chance where all others fail, yet experts caution that a single strike may not be enough to destroy the facility's deepest chambers. It may take not just brute force but a calculated strategy, or multiple hits, to crack open this vault. So the great question arises, can a bunker designed to withstand destruction actually be destroyed? Can one massive bomb truly take out Iran's most protected nuclear site? Or is Fordow simply too deep and too tough to fall? This is physics versus fortification, and the outcome remains uncertain. The B-2 Spirit, a stealth elite bomber, is the only aircraft capable of deploying the massive 30,000-pound MOP undetected. With only 2 bombs on board, it must traverse Iranian airspace without being intercepted, relying on stealth, terrain masking, and electronic countermeasures. However, the bomb depends on GPS for pinpoint accuracy, making it vulnerable to electronic jamming. A single interference signal could mean complete mission failure, even if stealth succeeds. Even a slight miscalculation, wrong angle or poor timing, could cause the GBU-57 to veer off course or detonate too early, leaving Fordow partially intact and reparable. Such a failure wouldn't just ruin the mission, it would damage the credibility of the superpower that launched it and expose the weapon's real limitations. Is there even a realistic plan B if America's most powerful bunker buster fails? Despite its capabilities, the US has been reluctant to use this weapon. In 2019, it held back, recognizing that the diplomatic fallout would far outweigh any military success. Attacking Fordow could trigger a chain reaction of geopolitical consequences, fracture key alliances, and destabilize entire regions. Is destroying an underground facility worth risking a global crisis? Meanwhile, the world is racing to dominate the underground battlefield. Although the US leads in developing deep penetration weapons like the GBU-57, other countries are quickly catching up. Israel, facing constant threats, has developed its own deep strike bombs to counter fortified targets in the Middle East. Europe, wary of relying solely on American tech, has quietly launched joint research programs, led by Germany, France, and the UK, to create advanced bunker-busting systems. China has entered the competition as well. Recent satellite imagery reveals tests of large, precision-guided penetrators targeting deeply buried command centers in Asia, posing a serious challenge to US dominance. With the upcoming B-21 Raider, America's capabilities are set to grow even further. But Fordow still operates, highlighting the current limits of bunker-penetrating technology. Yet innovation doesn't stop. Tools like laser drilling, AI-guided munitions, and drone swarms could soon revolutionize how deep targets are engaged. Ultimately, beyond all the engineering marvels and military tech, one essential question remains. If multiple nations gain the ability to neutralize the most fortified bunkers on Earth, are we truly increasing global security, or stepping into a new era of high-risk escalation and constant tension? What do you think? Should the world continue developing such devastating technologies, or is it time for humanity to rethink its approach to defense? Leave your thoughts below, share this content, and join the discussion. And if you're fascinated by massive engineering and military technology projects, subscribe now and become part of the millions exploring the future of global defense with us.